And my eyes are red. Okay, I need some Visine. Anyways, welcome, and this is the last class. And today I want to go over two things. One of them is the final, which will be available on May 12th at midnight. So you can do it on Thursday. And if it's not, please email me ASAP. The final is 15 questions, multiple choice. And hold on, can you put your headphone? You have it?
No, I will turn it down.
Okay, no, you can have my. You want my headphone?
Find out.
It's okay. Yeah, this is the problem with the battery. So what you have to do is just go through the multiple choice and try to do them. But they 15 questions again, one chance, 30 minutes. It's plenty of time. If you face some problems and you feel like the computer locked on you, just email me. I will reset it. And you have from the 12th till the 18th, so that's plenty of time. So what I want to do right now is go over the final topics, what's going to be on the final. And I think I put it over here. I'm going to share my screen with you now. Okay, so probably you can see my blackboard, and if you go into final exam, you will see the topics listed in here. So if you feel comfortable with these topics, you should be okay. And again, the exam is not tricky or anything. You just have to read carefully, and it's 15 questions. Reading, I did put the NFPA to skim through it. It's a good version. You can print it out. And as I've said last class, now for the oil burn exam, you do not need to read the CMR. All you need is the uh, NFPA 31. Okay. Final exam here is going to be available on midnight, May 12th. And the week video that I'm gonna put here is what we are discussing right now. So I'm gonna once it's done, I'm going to upload it and put it in here so people can watch it. So the first topic here that I want to go over is the BTU of the boiler based on the nozzle size. Can somebody explain or help me understand that? So what does that mean? Um, so if you think of what we did during the lab, we looked at the boiler, we saw the BTU, and we saw the nozzle size. So the BTU of the boiler can vary. There's lower limit and an upper limit based on how much BTU you want to produce. How is this calculated? We said 1 gallon, 1 gallon of fuel oil equal how many BTUs?
130,000.
138,000. So if the nozzle is 1 gallon per hour, so you think it's going to be roughly around that much BTUs. So you can change. So there's a lower limit, an upper limit, and you want to stay within that range. If for some reason that boiler allows you to increase the limit of BTUs, you can change the nozzle and you can look at the manufacturer based on the chamber size to tell you what is the limit of that nozzle as upper limit or lower limit. Any questions about that? The calculation. So if you have nozzle size of 0.75 GPH, how much is that? Basically, you will go and multiply 138,000 times 0.75. Voila, this is your BTUs for that boiler. Of course, this is the amount of theoretical BTUs in the fuel, so probably getting something around 90. If you have zero point 0.5 gallon, that's around 60 or 60,000 BTUs. Okay, that's the first thing. Second thing is distances and clearances of burner and tanks from the building construction. This information you will find in the NORO book, and you will find also in the NFPA. How far is the vent has to be from the window? How far is the boiler from any combustible material? How far from the wall? I'm going to ask you about that. Oil properties. What are the oil properties and where would you find that? Let me see if I have my NORA book. I don't think I have it with me right now, but if you check the NORA book on the first or second chapter, you'll see the oil property. And with that, I mean oil properties equal. What are they? Pure pour point. flash point, burn point, cloud point. These are all temperatures and properties. So look at them on the NORA book and review that. I'm trying to narrow down what you need to remember. And all these things actually is going to be beneficial because you will encounter them when you do your oil burner exam. Okay, causes of smoke and an oil burner. Just generally speaking, smoke is caused by many things. Could be too much air, too little air. Also, the flame is hitting the wall. The flame should not be hitting the wall too much. So if the flame is hitting the wall is not centered, probably it will cause you some smoke. Some residuals in the tank will in the chamber will cause you some smoke, and so on. So there's some causes of smoke inside the chamber. What is our target smoke? From 0 to 1 is acceptable. Any more than that, it's not acceptable. Calculation of percentage. Why do I need that? I think it's very important to calculate percentage. If I because you will run into that a lot when it comes to efficiency and reduction by how many percent reduction or increase. So if the for example, if the burner has 100 BTUs per hour, I want to increase that by 20%. What is the result BTUs? Is going to be 120%. Okay, so find your own way of understanding percentage when it comes to reduction or increase, so you can have a more accurate way to represent your case. And you can say, I'm increasing the efficiency by this and that, or I'm increasing the capacity by double, 50%, and so on. It will give you more credibility and more representation of numbers if you know how to calculate percentage. And people seem to kind of identify with that. Okay, flame detection systems, residential and industrial. Okay, so for residential, we have two means to detect flame: CAD cell, and that is using light, or stack mounted relay, obsolete and uses heat. Okay, so that's for residential. What about industrial? Can you give me some examples? I'll give you UV. You can use ultraviolet. You can use infrared. You can use light. You can use also ions, as in flame rods. Flame rods actually are used in gas sometimes. Sometimes they're used in oil, but they are mostly used with gas because they react to the ions in the gas. They are a very sophisticated way to measure flame and the amount of flame in there. So probably if you work with gas, you will see some flame rods, and I did put a lot of information on Blackboard about that. Basically, it does something just like it's called rectification, changing AC to DC. Anyways, it's one of the means to measure temperature. So, sorry, to measure flame, and go over the PowerPoint that describe that, because you need to know how each one of those functions. I mean, I don't think it's asking too much. It's just knowing different types of flame detection systems. There are questions about voltages, frequencies of residential and industrial boilers, voltages for control. What is the frequency limit? So most frequencies in for AC current are around 60 hertz, which is 60 cycles per second. Lower limit is 55. So any less than that, and you might have issues. Okay, I will ask you a question about adding resistance in series. How do you spell series? And parallel. So it's going to be simple, but I did say from last semester that I'm not going to stop doing this. It's very, very important. In series, you just add them up. In parallel, the result of your calculation should be smaller than the smallest resistance in the parallel circuit. So it's not going to be very complicated, just a very simple resistance. You just add them. That's adding resistances in series and parallel. Function of industrial flame detection system. We did I just mentioned that. This is really good. That's the confined, how did I spell that right? Who cares? Anyways, confined space calculation. What is considered confined space? So according to the CMR and FBA, it is 50 cubic inch for each 1,000 BTU. Less. So anything less than 50 cubic inch for 1,000 BTU is considered confined space. Why do we need it's a confined space? To know it's confined space because that will dictate the what do we have to do for that boiler. If somebody's going to put a boiler in a closet, we have to say that's the confined space and that's not possible. So you have to put the boiler in a place that is not considered confined space. Types of combustion fuel. What kind of combustion fuel do we have? It's good to know that there are more than one. It's not only type, it's not number two fuel oil. What is number one fuel oil? Kerosene. So when you, this is again kind of mostly petroleum, but when you distill crude oil, the lightest fuel goes in the top of the distillation column and the heaviest stays in the bottom. So number one is the lightest, which is kerosene. Heavier comes number two, diesel. Number three, number four, number five, number six looks like honey, and it becomes less viscous. So you need to know that what is available for us. And actually, there are some places here where they still use charcoal. Is it charcoal? Yeah, industrial coal for heating or different kind of fuel. They require different applications. They have to be heated. Some of them have to be mixed. But you need to know that there are different kind of fuel. And let's say you live in New Hampshire and you have a small little house. You don't have a basement, and you have your fuel oil tank outside, and it's going to be below freezing. What are you going to do? Yeah, you add up to 20% kerosene. It will kind of dilute it and make it not freeze. Okay, so freezing point depends on the chemistry of the liquid. Probably you've noticed that if you put a bottle of alcohol in the freezer, it does not freeze, right? So the amount of water and liquids do freeze at a different temperature. Okay, so that's is going to be the material of this final exam. So I'm going to stop the video right now so I can post this as 20 minutes in the Blackboard, and I'll go back and start keep recording so we can do the questions. Okay, stop recording.